In this video, we'll talk about what U-substitution is. So I want to motivate this with an example. So let's try to evaluate the integral of x over the square root of 1 plus 4x squared dx. So we want to find an antiderivative of this function. So with this function, we don't know how to do it using our current knowledge of antiderivatives. This isn't a function that I just have a formula for to compute the antiderivative of. So here's the idea that we're going to use. I'm going to make a substitution. I'm going to let u be equal to the thing inside of the square root, the 1 plus 4x squared. And then I'm going to take the derivative of this. So du dx, this derivative will be 8x. And now the du dx, so we've learned before that this is just a notational thing. It's not technically a fraction, but I'm going to treat it like a fraction. I'm going to now treat it as a fraction, even though it's not. Even though it's not. And let's see what happens. So what I'm going to do with this is sort of move the dx over. So I'll get du equals 8x dx. And now what I want to do is, because I let u be 1 plus 4x squared, I'm going to be able to plug that in to my integral for where that denominator is. I'm going to now isolate the dx. So we are going to isolate this dx. And to do that, I divide by the 8x. So I'll get du divided by 8x equals dx. Because once it's isolated, I will now get to plug that in to my integral where the dx is. So essentially, now I know dx is this, I'll get to plug that in for the dx. And because I know u is this, we'll get to plug that in where the u is. All right, so we are ready to substitute. Okay. So when we do that, we get our integral. Let me zoom out a little bit more. We have that x on the numerator. On the bottom, we'll get square root of u. And for the dx, we've seen that that is du over 8x. So now, something really nice happens. The x on top cancels with that x on the bottom. And what I'll get, so this 8 is a constant. It's multiplying this thing. I can pull that to the front as a 1 over 8. And then I'll be left with this 1 over square root of u, which I can rewrite as u to the negative 1/2 du. And now all of the x's are gone, and the only variable I have in this is u. Once our integral is purely in terms of u, we can integrate it. And when I say integrate, that's just going to be another way for me to say take the antiderivative. We can take the antiderivative of this function. All right, so we'll get the 1/8 staying outside, and then I do reverse power rule on the u to the negative 1/2. So I'll add 1 to the power to get u to the 1/2, and then I divide by the new power. I divide by the 1/2. But when I divide by 1/2, that's the same as multiplying by the reciprocal, which will be 2. Okay, so we'll get times 2 to the 1/2. This is an indefinite integral, which means it's a general antiderivative. So I got to write a plus c. Okay. All right, so I've done my antiderivative. But remember, my original function was in terms of x. So I need to substitute back to get my answer in terms of x. So we need to now substitute back. So we will substitute back. In doing that, and let me also simplify a little bit. 1/8 times 2, that's going to be 1/4. 1/4. And then I'll get, instead of writing u to the 1/2, let's write what u is. U is 1 plus 4x squared. So we get that whole thing to the 1/2 power, and then plus the c. And that's my answer. We've just done the antiderivative. Okay, well, let's check this. So let's check our answer by differentiating, by taking the derivative. So we've seen that before. When you do an antiderivative, you could check that it's right by just taking the derivative and making sure that we get our original function. So let's take the derivative of this thing. So we're going to take d dx of 1/4 times 1 plus 4x squared to the 1/2 plus c. Okay, so to do this antiderivative, we're going to have to do chain rule. We will need chain rule. Okay, so what will happen is at first I deal with the outside function, that 1/2 power. That'll come down. It'll multiply the 1/4. So I get 1/4 times the 1/2 comes down. And then that I keep that stuff, the 1 plus 4x squared. I subtract 1 from the power to get negative 1/2. But then I do the chain rule step and I multiply by the derivative of the inside, which is 8x. Okay, and then the derivative of that plus c, that's going to be 0. Okay, so we get some cancellations. This 4 and the 2 become an 8, and that cancels this 8. Okay, and then I can leave this x at the top of the fraction. And then this whole thing to the negative 1/2, I can bring to the denominator as a square root. So I get square root of 1 plus 4x squared. But that was our original function. So I'm going to put a check mark next to this. That means we've done this correctly. All right, so I want to mention a couple of notes. So the first is that this method is called U-substitution. So we do the substitution by letting u be equal to some quantity. And U-substitution, I'm going to abbreviate U-sub. U-substitution, it turns out, is the chain rule, but in reverse. It's the chain rule in reverse. Okay, so let's see why that is. Recall that with the chain rule, we're taking the derivative, d dx, of f of g of x, of a function inside of another function. And the chain rule says, take the derivative of the outside, f prime, but keep plugging the same inside thing in, g of x, but then multiply that by the derivative of the inside, g prime of x. Okay, so if we write this in terms of antiderivatives, the integral, the general antiderivative of f prime of g of x times g prime of x. So the antiderivative of this would have been this original function, f of g of x, and I got to put a plus c because this is an indefinite integral, which means it's a general antiderivative. So what I'm going to do now is show what happens to this if we make a substitution. I'm going to let u be equal to g of x. So if we do that, this integral that we have of f prime of g of x times g prime of x dx, this will be equal to, and this quantity becomes f of u when I make my substitution, plus c. Okay, so I'm just moving up my work to the top of the page to give myself some more room. So this f of u plus c, we could also write this as an integral a little bit more simply. This would just be the integral of f prime of u du, because the general antiderivative of f prime of u would just be f of u plus c. Okay, so what we've shown is this integral that we started off with, this f prime of g of x times g prime of x integral, that's the same thing as this integral of f prime of u. Okay, and we know that u equals g of x. So that means this g of x here is equal to the u there. So the f prime portions of these integrals are the same. Well, that means that the other portions are also going to match up. So the du here should match up with the g prime of x dx over here. Okay, so because of that, we now know that du will be equal to g prime of x dx. And if we were to just take our substitution, u equals g of x, and take the derivative of both sides, we would get du dx equals g prime of x. So because both of these statements are true, this one with the du and this one with the du dx, that's why when we did our step where we sort of treated the du dx as a fraction and just moved the dx over to get it in this form, that's why it was okay. Okay. So we can state this result more formally with the following theorem, which I'll just call the U-substitution rule. And it says that if u equals g of x is differentiable and its range is an interval I, and f prime is continuous on the interval I, then the integral of f prime of g of x times g prime of x dx, I can rewrite this integral as the integral of f prime of u du. So we can rewrite it in this simpler form. So our goal with these U-substitution questions is we will have these antiderivatives which look like derivatives of chain rule, but they'll be in disguise. It won't always be obvious that they are a derivative of chain rule. Our goal is to get these into the form integral of f prime of u du by doing some U-substitution. And once we do that, this form is easier to integrate, and that's what we want. U-substitution can make integrals easier to do. So in terms of our goals for this section, we finished goal 1, introducing what U-substitution is.